In this video, we will be discussing regular polygons and some formulas involving how to calculate the measure of angles associated with regular polygons. So to start, a regular polygon is a polygon that has all its sides congruent and all angles congruent. Now, one thing to keep in mind with regular polygons is just because a figure has all its sides congruent, that does not necessarily mean all of the angles are also going to be congruent. But some of the regular polygons that we've already discussed in this class, our quadrilateral regular polygon has a special name. That would be the square, because we know in a square all the sides are congruent and all of the angles are congruent. All the angles are actually right angles. Our three-sided figure would be the equilateral or equiangular triangle, because we know that that means all sides and angles are congruent. This next one is just called a regular pentagon. So it doesn't really have a special name, so we just put the word regular in front to indicate that all the sides and all the angles are congruent. So anytime you see that word regular, that's how you know that all the sides and all the angles are going to be congruent. And then this last one is just called a regular hexagon. So these are just a few examples of some regular polygons. Now, to calculate the measure of each exterior angle in a regular polygon, we'll recall that to calculate the sum of all the exterior angles, that's always going to be 360 degrees. So to calculate each exterior angle in a regular polygon, well, since all the angles are congruent, that means all the exterior angles are also going to be congruent. So we're just going to take 360 and divide it by the number of sides. Now I want you to think about this next question here. What is the relationship between each interior and exterior angle in any type of polygon? Doesn't necessarily have to be a regular polygon, but think about that for a minute. Maybe draw an example of a polygon and then draw its exterior angle and think about what is that relationship. So in this example, I have drawn a triangle. Angle 1 is the interior angle. Angle 2 is the exterior angle. What do we know is the relationship between them? They're always going to be supplementary. Now, if we keep this in mind, if it asks you to calculate each interior angle in a regular polygon, since we know that the interior and the exterior angle are supplementary, the first thing I would do is calculate the exterior angle by doing 360 divided by the number of sides. Then if I want to find the interior angle, I'm just going to take the supplement of that. So I would subtract that answer from 180. So if you're looking to calculate each interior angle in a regular polygon, you may want to think of this formula here. Or just remember that they're supplementary and you don't even really need to memorize that. The next question I'd like you to think about as well. Which polygon has each exterior angle congruent to each interior angle? Now, because it doesn't say that all the sides are congruent, the most descriptive name for this shape would be a rectangle, because we know that the interior angle is equal to 90 and the exterior angle. If it said all the sides were congruent, or if it said that this was a regular polygon, then your most descriptive answer would be a square. Okay, so let's take a look at some examples. In number 1, it asks you to find each exterior angle in the regular polygons, and then in number 2, it asks you to find each interior angle in those regular polygons. So using what we just discussed, I'd like you to take a minute, calculate these out, and then I'm just going to have you simply check your answers. These should be very easy, very straightforward for you. So pause the video now, work them all out, and then press play when you're ready for the answers. Alright, so hopefully this was fairly easy for you. So let's check our answers to number 1, where it asks you to find each exterior angle. 1A, a regular hexagon, each exterior angle is 60 degrees. 1B, a regular dodecagon, is 30 degrees. 1C, a regular pentadecagon, is 24 degrees. And then 1D, a regular thirtygon, each exterior angle is 12 degrees. Now moving on to number 2, it asks you to find the measure of each interior angle. 2A, a regular nonagon, each interior angle is 140 degrees. Notice that first I found the exterior angle and then I just took the supplement of that. 2B, a regular pentagon, each interior angle is 108 degrees. 2C, a regular decagon, each interior angle is 144 degrees. And then 2D, a regular 20gon, each interior angle is 162 degrees. So hopefully you kind of have a better idea of what a regular polygon is and how to calculate the measure of each interior and each exterior angle. Be careful in this chapter when you're reading the questions, especially on the quizzes and tests. There are a lot of different formulas, and it's very easy to mix them up, especially if you're not reading the questions carefully. If it says to find each interior angle in a regular polygon, then you're going to use the formulas we talked about today. But if it says to find the sum of the polygons, then make sure that you use the formulas from section 7.3. So just definitely read those questions carefully.